Hey guys, this is Miss Adams again. So we are actually getting into the meat of this lesson now. So today's whole lesson was really centered on graphing systems of linear equations. AROC and graphing linear equations, that was mostly a review from what you've done in pre-algebra, but now we're going to talk about something a little bit different from pre-algebra. We're now going to graph two lines on the same coordinate plane and figure out what their intersection is. So in order to do this, we've got a few steps. So our first step is to convert each equation into slope-intercept form, if necessary. They may already be in slope-intercept form. And then from there, we're going to identify the slope. You also could call that the AROC. That's your average rate of change. And the y-intercept of each equation. Then you're going to graph each equation on the same coordinate plane. And remember, your solution for the systems of linear equations is the intersection. So anytime you hear us say determine the solution of the systems of equations, you're trying to find your intersection point. Well, there are actually three different ways that or three different numbers of solutions that could happen here, or three different possibilities, there. So you could have just one solution, which is most common, which means you've graphed two lines on the same coordinate plane and they have one point of intersection. Or you can have an infinite amount of solutions, which means these two lines have the same slope and the same y-intercept. So one may be written in standard form, one may be written in slope-intercept form, but they are the same line. And when you graph them, every point is an intersection point because they're the same. And then you could have the possibility of no solutions. That means that these two lines don't touch. They have the same slope, but different y-intercepts. That means the two lines are parallel, so they will never intersect. So these are our three possibilities for solutions. So let's look into graphing some of these systems. So in this case it says graph y equals negative 3x plus 5 and y equals 2x minus 5. So I'm going to color code it a little bit. I'll do the first one in purple and the second one in this pretty pink color. So I've got y equals negative 3x plus 5. That's going to be the first line I look at. So let's define some things here. So if I'm looking at y equals negative 3x plus 5, our first thing we need to define is our slope, or our AROC. If I'm looking there, I know that's going to be our m value because y equals mx plus b. So I have a slope of negative 3, which means I'm going to go down 3 and to the right 1. Because remember, you could write that as a fraction as well. And then if I'm looking at the y-intercept, that's our b value. That's at positive 5, so I'm going to write that as 0, positive 5. Looking at the second line, it says y equals 2x minus 5. So I know I'm going to have a slope of 2, and that could be written as 2 over 1, which means I'm going to go up 2 and to the right 1. And then my y-intercept is negative, so it's at the point 0, negative 5. So let's plot those. So I'm starting off with my first graph here, y equals negative 3x plus 5. I'm going to start off at positive 5. I'm going to go down 3, so down to 4, 3, 2, so that's 1, 2, 3 spots, to the right 1. So I'm going to have a second point there at 1, 2. If I went down to a third point, I could also go down 3 again, so 1, 2, 3, to the right 1. So I'd have a point at 2, negative 1. I'm going to graph that line. Try to be as precise as possible. And then I'm going to have my next graph starting at y-intercept at negative 5. And it has a positive slope, so I'm going to go up 2 to the right 1 to get to the point 1, negative 3. And I'm going to do that again. I'm going to go up 2 again to the right 1. And I'm going to be at the point 2, negative 1. If you notice, they both share this point, 2, negative 1. Guys, that's your solution. That's your intersection. Because if I continue on, if I graph this line, it's going to look something like that. And our intersection here then is at the point 2, negative 1. So that is your solution. So I'll let you guys try the next one. We're going to look at one, though, where we're not given both of them in slope-intercept form. So if I go to example 2, it says graph negative 9x minus 3y equals 6 and y equals 3x minus 8. So our second line is already in slope-intercept form for us, so that one's pretty easy. I can say that our slope, or in this case, let's use our AROC, which is also your slope, is 3. I'm going to say that's 3 over 1, so that's up 3, right 1. And then my y-intercept is at 0, negative 8. So I'm going to start off at negative 8 and go up 3, so 1, 2, 3 to the right 1. So that gets us to the point 1, negative 5. Do the same thing. I'm going to go up 3, so 1, 2, 3 to the right 1. That gets us to the point negative 2, or excuse me, 2, negative 2. And I could keep doing that. I could keep going 1, 2, 3 up to the right 1, 1, 2, 3 up to the right 1, 1, 2, 3 to the right 1, 1, 2, 3 to the right 1, just to make my graph look a little bit better. That way I know which intersection points I have here. That way it looks a little bit nicer on our coordinate plane. But now we've got to convert negative 9x minus 3y equals 6 into slope-intercept form, which means we're going to be solving for the variable y to get to y equals mx plus b. So first things first is to isolate your variable term, which in this case is negative 3y. So I want to get rid of the negative 9x on the left-hand side. In order to do that, I'm going to have to add 9x to both sides. That is your addition property of equality. So I now have negative 3y equals 9x plus 6. Then I'm going to divide by negative 3, since currently y is being multiplied by negative 3. I'm going to do the opposite and divide by negative 3 to both sides. That's your division property of equality to get that y equals negative 3x minus 2. So that's our equivalent equation to negative 9x minus 3y equals 6. It's just now in slope-intercept form. And we'll have a slope, or an AROC, of negative 3 over 1, and our y-intercept is at 0, negative 2. So I'm starting off at 0, negative 2. I'm going to go down 3, so 1, 2, 3 to the right 1. I can continue on, so go down 3 to the right 1. I could also go up 3, so 1, 2, 3, but to the left 1, because up is a positive direction, left is a negative direction, it still has a negative slope. So I continue going 1, 2, 3 up to the left 1, 3 up, left 1, 3 up, left 1. Graph my line. And remember, the solution of the systems of equations is where the two lines intersect. So in this case, we have an intersection point at 1, negative 5. So our solution is 1, negative 5. Let's do one more example together, and then I'll let you guys practice. I believe we have one more. Yep. Alright, let's look at this last one here. it says to graph y equals 2x plus 2 and y plus 1 equals negative x. So our first one is in slope-intercept form. That makes it easy. Our slope is equal to positive 2, so that's the same thing as saying 2 over 1. You're going to go up 2 to the right 1, and your y-intercept is at 0, 2. So I'm going to start at positive 2, go up 2 to the right 1, up 2 to the right 1, up 2, right 1, up 2, right 1. You also can go down 2 to the left 1 because negative divided by negative is a positive slope still. So down 2, left 1. And that'll just help you graph your line a little bit better. But now we've got to get this second equation, y plus 1 equals negative x, into slope-intercept form, which again is y equals mx plus b. So I'm starting off with y plus 1 equals negative x. I need to isolate y, so I'm going to subtract 1 from both sides. So I'm going to end up with the equation y equals negative x minus 1. That is the equivalent equation to y plus 1 equals negative x. It's just now in slope-intercept form. So our slope here is the number in front of your variable x. If there's not a number there, but there's a negative, we understand that to be negative 1. So your slope is negative 1. And your y-intercept is 0, negative 1. So I'm going to start off at the point negative 1. I'm going to go down 1 to the right 1, down 1, right 1, and just keep doing that. Keep going down 1, right 1, making as many points as you need to graph the line properly. You can also go up 1 and to the left 1 because that's still a negative motion. And you just keep graphing the points as need be using the slope. And if I graph that line, we have an intersection point at negative 1, 0. So that would be your solution, negative 1, 0. Alright guys, and that is graphing a systems of linear equations in order to find the solutions. Good luck!